All right, so last time we were looking at significant figures, numbers that statistically had value to them, okay? Now we're going to take it to the next level, and you're like, uh-oh. We're going to look at how we multiply, divide, add, and subtract with these numbers. How do we figure those numbers out when we start adding and subtracting or multiplying and dividing them? Which ones would be considered statistically, if I can ever say it, significant, okay? So, first off, we want to talk about rules for Sig Figs in mathematical operations, specifically multiplication and division, okay? So when you're multiplying and adding numbers together, then you come up with an answer. How many of those numbers will be statistically significant? How many Sig Figs we have? So it says the number of Sig Figs in the result equals the number in the least precise measurement used in the calculation. So when they said, let's do Sig Figs, they came up with rules for these in math. And if you got two numbers that you're multiplying or dividing together, you're going to pick the one that has the fewest Sig Figs. That's how many Sig Figs you're going to have with your answer. Okay, and I'm going to show you what I'm talking about in just a second. For example, 6.38 times 2.0. All right, when you multiply those together, right, you should get 12.76, right? That's what the math says when you do it in the calculator or do it in your head. 12.76. But if you look right here at it, you've got right here, oops, here, let's give it a better color. Right here, you've got 3 Sig Figs, and right here you have 2 significant figures. That 2 and that 0 count. These 3 do. So your answer has to have only 2 significant figures. 12.76 has 4 numbers, doesn't it? So we got to get that down to just 2. Well, if we take 12.76 and look at that 7, because these are the ones we're going to be worried about, that 7 is going to make that 12 turn into 13. And that gives us those 2 significant figures. Okay? And you see that's a rounded number, isn't it? 12.76 rounded to 2 Sig Figs is only 13. Now again, this is what we're talking about when we're talking about significant figures and the rounding that you do to get the least number of significant figures from your question, okay? So that's pretty straightforward, but what we're going to do now is we're going to practice several of them, okay? And I'll show you what I'm talking about. So, if I have this number right here, 3.24 meters times 7.0 meters. When you type it into your calculator, you're going to get 22.68 square meters, okay? But again, if you look here, let's get it right here. I have 3 here, and I have 2 here. Well, right here I've got 4 numbers. So I got to make that number only have 2 Sig Figs. Well, so somewhere right here I got to split this off. 22. But that 6 rounds that 22 up to 23 square meters. Okay? Are we okay so far? If you're not, again, when we get through, email me and we'll go over some of this stuff, okay? I'll do maybe another video of this to kind of help you go through it, okay? The next one, 100.0 grams divided by 23.7 cubic centimeters. When you do the calculator math on it, this is the number you get, 4.219409283 grams per cubic centimeter. None of us want to write all that number down, do we? So what we do is we look here. We've got 4 Sig Figs, and here we've got 3 significant figures. So our answer has to have 3 significant figures. Well, so that means we're going to look at these first 3 right here. Those are my first 3 numbers, aren't they? But what do we do here? I got that 9 right there. What do you think that's going to do to that 1? Well, 9 rounds that 1 up to a 2. So my answer should be 4.22 grams per cubic centimeter. Okay? All right. We'll keep going here. 0.02 centimeters times 2.371 centimeters. This is what I get, 0.04742 square centimeters. Again, only 1 here and 4 there. So my answer has to have one significant figure. Now the thing is, these aren't statistically significant anyway, are they? So those leading zeros, they don't count in the first place. So we ignore those. We look right here. That 4 is my first significant figure. Remember, because these are just placeholders, right? They hold your place in your decimal. Now that 7 makes that 4 a 5. So when I get through with it, I'm going to have 0.05 square centimeters. We still have to put those 2 zeros there. They're placeholders for the decimal, right? So they still have to be there, okay? But the only one significant figure is that 5, because we turn that 4 with that 7 into a 5, okay? 710 meters divided by 3.0 seconds gives us 236.666667 meters per second. Again here, 2 sig figs, and same thing here, 2 sig figs. That 0 doesn't count because there's no decimal, right? So my answer has to have 2 significant figures. Now this is where people get kind of stupid, okay? I don't know why, but they do. That 3 is going to be rounded up to a 4, right? I have a lot of people, though, they want to put 24. That's not 24. That's 236, right? If I round that 236 up, it's going to be not 24, but 240. Because remember, that 0 right there is not significant, is it? The trailing 0 with no decimal means it's not statistically significant. But I still need it in the actual answer, don't I? All right. Otherwise, 24 ain't right. It's not even close. All right. How about this one? 1,818.2 pounds times 3.23 feet. When I do the math, I'll get 5,872.786 pound-foot. Now, I got 5 here, and I got 3 here. So my answer has to have 3. So if I do this, 5,872.786, those are the 3 significant ones. That 2 is not going to be significant, but what I got to do, is that 2 going to affect that 7? No, it's going to stay the same. So when I get done, it should be 5,870 pound-feet. Okay? Pretty straightforward, isn't it? As long as you're careful. And if you're not careful, you're going to cause some problems to occur. All right, and the last one here, 1.030 grams times 2.87 milliliters. Do the math on it. This is what we get. 2.9561 grams per milliliter. I have 4 sig figs, because again, captive 0, trailing with a decimal, so that's 4. I got 3 here, so my answer has to have 3. So that 2.9561, that 6 makes that 5 a 6. So this should be 2.96 grams per milliliter. Okay? So this is multiplication and division with significant figures. Okay? Now the next video is going to be on addition and subtraction, which also has a different set of rules. They're not hard rules. It's one pretty straightforward rule, but it's different than multiplication and division.